Let's make sure where we locate the slab so that every time it's not moved. So suppose if I put the light here, right? So you see the line there, right? So if I take a rough line like this, it goes something like this, right? Approximate lining. If I put it here, so the light is coming somewhere here. Okay, just take it out. So I think this was somewhere here. So what I'm trying to show you here is the light is kind of going here, but then here it will go something like this. In reality, what's happening is there is a refraction. So if I can keep it in. So as I said, if you really want to do this very well, right, you have to do it in a paper. Okay? And if you do it in the paper, yeah, so if you do it in the paper, you will get a nice diagram like this. Okay, so what this will show you is, if you send the laser light like this, right, this is my angle of incidence. The light was supposed to go straight, but then there is a change in medium. So what does it do? Rarer to denser. So this is rarer, this is denser. So will it go towards the normal or away from the normal? Towards the normal. So instead of going like this, it will go like this. Okay, and this is what we call it as angle of refraction. Okay, and then after coming here again you put a line. So now this is denser to rarer. So the line is supposed to go like this, but then denser to rarer go away from the normal. So it will go like this. Okay. So if you really draw this properly, so what you will see is this line, right? So this line is supposed to go like this. This line and this line will be parallel. Okay. So this light was supposed to travel like this, but then because of this rectangular slab, it got refracted twice. And this line will be parallel. So instead of going here, it is shifted here. So we call this as lateral shift. Okay. Lateral means side. So sideways shift. What do you mean by equilateral triangle? Equal sides. Okay. So lateral is side. Is this clear? So now important question. So look at this. If this is R, what is this? If this is R, this and this are vertical. That means if this is R, this is also R. Do you agree? And this is, let's call it as, this is air and this is glass. So refractive index of glass with respect to air is equal to sin I by sin R. I told you glass is where the refraction is happening. Okay, this is incident. This is the place where refraction is happening, which means the place where the refraction is happening, this is what you have to write here. So it's refractive index of glass with respect to air. Okay, so the way you have to read this is glass with respect to air. Okay. Or some books will use 2 with respect to 1. It's all the same name. Okay. 2 is your medium 2 and then this is medium 1. So very interestingly, right, when this is coming out, NA with respect to, so please listen here. So in this, inside this glass, this is my incident ray. This is my refracted ray. So the refraction is happening where? Air or glass? No. Where is the refraction happening? This is incident ray. This is refracted ray. So the refraction is happening here. Yeah. So that means I have to write NAG is equal to sin R. Due to the geometry, I know that this and this are equal. So sin R by. So according to this, right? So I don't know this. Let's say I don't know this theta. I'm taking this theta. Okay. That means it will be angle of incidence by angle of refraction. Snell's law. Okay. But then from our experiments we know that this and this are just reciprocals, right? What is this? Ng by Na. So this is nothing but velocity in air divided by velocity in glass. What is this? Velocity of glass divided by velocity of air. Are you following this? That means, looking at this, what can you say? This and this should be reciprocal. Okay. That means Nga is nothing but 1 by Nag. That means Nga is sin I by sin R. 1 by Nag would be sin theta by sin R. R and R are same. So what can you say about I and theta? I should be equal to theta. So this theta is nothing but I. So if this is angle of incidence, it will be coming out at the same angle. Or in other words, if this is the path of light, right, which is sent like this, right? If I, in this experiment which we did here, if I send the light from here, it will be coming out here. Okay? We have a special name for this. What is that called? Property of light. What property is that called? Any idea? If I send the ray this way, I will be getting the laser ray right this way. But if I am sending it through this way, I will be getting through this. What is it called? It is reversible. So it's called reversibility of light. So this property of light tracing back the same path is called reversibility of light. Okay. So the best way to do these kind of experiments is laser, because laser is very powerful and you can see the ray. Okay. If you put some torchlight kind of things, it's not very powerful, right? You will not be able to do these kind of experiments. So you need to have a laser. These kind of simple lasers, I am sure you can buy it in your stationery shop for less than 100 rupees. You can buy it. But still, you have to be careful. Don't put on somebody's eyes or something. It's dangerous. Okay, so this is refraction through a glass slab. So the topic here is taking down refraction through a glass slab. So if you have any confusion here, please, I hope you are okay with these things. Maybe you may have some doubts here. So what is refractive index of glass with respect to air? Velocity in air divided by velocity in glass. So it will be other way around. Okay? It's not Vg by Va, it's Va by Vg. Because Va is something like speed of light in vacuum, very close, 3 into 10 power 8. This one is the other way around. So Vg by Va. Okay. Then let's talk about apparent depth. Okay, here is a concept theory, right? But you may get some numericals based on this angles. Okay. So for that, they may ask you to find this lateral shift. So it's all just simple trigonometry. Okay. So let's say this is the lateral shift, which is, let's call it as, okay, lateral shift, let's call the same thing. And this is thickness of the glass slab, T. Okay. So one which I'm writing in black, it's more for your numericals. Okay. It may ask you some numericals based on this. let me say, so look at this and then this one. So I want this one. If I have this, so let's see, I theta, so I want r, so I minus r. So I want this one, right? So look at this one. This is I, this is r, right? So what can you say about this angle? I minus r, because this entire thing is I, but refraction is happening here, so that means this must be I minus r. Okay. You also try to write it in a different color so that it's easy for you to understand. That's a separate derivation. This one is separate. Okay. So now I want this one. I have this angle, right? So suppose if I know this hypotenuse, right? This is in this triangle. This is my hypotenuse. So if I know this and this, I can simply say this is opposite angle, right? So sine I minus r is equal to this by this. Anyone following that? How do I find this thing, this hypotenuse? I know this triangle, I know this triangle, I know this one, and this thickness is t. So how can you connect this and this? So let me redraw this here. This is r, this is t. I am asking you how to find this hypotenuse h. Suppose if I know these two things, can I say cos r is equal to adjacent by hypotenuse, right? So that means I can find h is equal to t by cos r. Okay, so it's always a good practice to draw the triangles separately. Okay, if you try to show everything here, it's going to be very busy. You will not be able to follow it later on when you come back. Okay. So now I found the hypotenuse. So in this triangle, so look at this triangle. This is my lateral shift Ls. This is my I minus r. So this is h, right? So tell me how to find this one, Ls, lateral shift. You can take sine theta, right? So sine I minus r is equal to opposite by hypotenuse. Actually, I have not drawn this correctly. So here it is 90 degree, right? So it should go something like this. So here it is actually 90 degree. So that means this is hypotenuse. So that means it will be opposite by hypotenuse. But hypotenuse, I know it is t by cos r. So that means I can say lateral shift is equal to t by cos r comes on this side. So t by cos r sine I minus r. Okay. Okay. In your textbook, what happens is they don't give you all these details, but then they will ask you in the numericals. Okay. Only if you know all these things, you will be able to do the numericals. Otherwise, you will not be able to do it. Everyone getting the idea? If you see it as a big derivation, you will think it is a big one. But if you look at this triangle, right? So please listen carefully. Let me repeat one more time. If you know this line, I can easily find sine I minus r is equal to this by this. This is what I want, right? How do I find this? I know this and this. That means I can say, using the cos formula, I can use cos r is equal to this by this, which means I can find this. So it's very simple. Okay. If you don't understand that, then you will be thinking it's a confusing thing. Anybody having any issues, doubts? If you have doubts, clarify immediately. Okay. If you know the theory, you can do the numericals very easily.